Hello everybody, my name is Ethan. Welcome back to the channel where today we are going to be continuing our C# lessons and doing an introduction to static. I am really sorry if you hear some vibration. Neighbors across the street are of course mowing the lawn as it just rained outside, so it's the perfect chance and opportunity to mow the lawn. So I'm hoping that isn't too loud and distracting throughout the course of this video, but let's jump right into it in our introduction to static. At this point, you may recall a custom data type is defined by a class. If you don't know what a class is, please go watch my previous video on C#, and I covered the basics of classes, such as how to define a class and other class features, so go watch that. An instance of a class is called an object. Multiple unique objects can be instantiated from one class. This process of bundling related data and methods into a type is called encapsulation, and it makes code easier to organize and reuse. So that's a bit of a recap. Now, for today, what if we needed to do something related to the type itself, not instances of that type? For example, where do we store the count of all forest objects, or an explanation of forests in general? To keep the rules of encapsulation, these shouldn't be associated with one instance because this information is related to the forest class, not a single forest instance. These facts and behaviors should be associated with the class itself. We call these types of members static. This lesson will cover the meaning of static, how to apply it to different types, class members, and its typical use cases. The forest class is defined in forest.cs. Make sure you're familiar with it before moving on. We'll be adding to this class throughout the lesson. Testing this kind of code takes longer, so some checkpoints in this lesson will need to take more time to run. It's worth the wait. So if you didn't watch the previous video, this is kind of what we worked on in the previous video. We created this class called forest. And in forest, we had a bunch of different things. First and foremost, we kind of talked about what public versus private was. We created some variables inside. We added some constructors to forest, as you can see here and here. And then we also have some properties. So the name of the forest, the amount of trees in the forest, the biome of the forest, and the age of the forest. And then we had a couple different methods added inside. One called grow and one called burn that would add trees and age, or subtract trees and age. So let's continue on to static. So static fields and properties. You already know how to create a field and property like this. So we have a class, we have a field, and then a property for that field, right? Definition, get definition, definition equal value. The definition of what a forest is applies to all forest objects, not just one. There should only be one value for the whole class. This is a good use case for static field / property. To make a static field and property, just add the static keyword after the access modifier, public or private. So we have private static string definition, public static string definition. Remember that static means associated with the class, not an instance. Thus, any static member is accessed from the class, not an instance. So we would do forest.definition, right? Instead of trying to create a forest instance, we would just actually put in the class. If you tried to access a static member from an instance like f.definition, you would get an error like static member forest definition cannot be accessed without with an instance reference. Qualify it to make with a type name instead. In the previous exercise, we mentioned storing the count of all forest objects. We'll use a static field and property to store that. Define a private static field named forests created. So again, we'll do something similar that we see up here. We're going to create it though called forests created. I'm going to do it in the properties area here. So we'll create a new one called private static, and in that case it's going to be a count, right? So it would be presumably an int variable called forests created. And then we'll open that up. And inside that, we're going to first leave it blank. Hopefully we did this right. And it did mention that it was going to take a little bit longer, and it looks like we didn't create it correctly. Oh, I guess it wants us to create the field first. So let's, instead of adding it in properties, we'll go up to fields and add it that way and see what happens. And again, it's going to take a little bit longer today, but hopefully we can get through this. Okay, so we created it. Now let's define a public static property named forest created, give it a public getter and private setter. So now we'll go down to the properties here. We'll do a public static int property named forests created. And in this, we will have a public getter, public get, private set. It doesn't tell us what we want to do within that, so I'm going to assume it's just the generic get set. So that wasn't exactly what we wanted to see there. Let's close this message down below here. And we will define a public static property named forests created, give it a public getter and a private setter. And public static int forests created. The getter should be the public and return. Okay, so I guess we can write this out as we'll write it out actually. Forests created. Open this up and we'll say forests created equal value. I thought I was taking a little bit of a shortcut there. It's still not correct. Let's take a peek at the hint. We already kind of did. I feel like I'm doing it correctly, but let's see what I'm missing here. So in as you can see, I have moved the semicolon. I guess I should have checked up here. It said semicolon expected, so I had moved the semicolon inside or outside of that when it should be inside. So now this should work. And in line 29, it's having an issue here with that. Let's see if I'm still missing the idea of what it wants me to do. So when I look at it, it looks exactly identical to what I have, but I guess let's go down here. Oh, did I click? I did click accidentally replace code. Not exactly sure what I was getting wrong there. I just had it up here instead of down here. Possibly could be messing with something there. In the last step, in the first constructor increment, so it replaced this forest created and we added the plus there, right? All right, that was a little bad, but let's go on to static methods. You already know how to create an instance method like class forest, private, and then we do definition, and then we console write line it. This behavior, printing a general definition, isn't specific to any one instance. It applies to the class itself, so it should be made static. To make a static method, just add static after the accessor modifier, public or private. So we add in here a private static string definition, and then we add that and say void because there's no real return value. Notice that we add static to both the field definition and method define. This is because a static method can only access other static methods or members. It cannot access instance members. So this would throw an error because definition is not static. Otherwise, static methods work like any other methods. Earlier, we mentioned storing an explanation of forests in general. We'll use a field and property to define an explanation. Define a private static string field named tree facts. Okay, define a private string static named. So we'll create a new one called a private static string named tree facts. Did that. Let's define a public static property named tree facts with no getter, with just a getter, no setter. So in properties, I'm going to scroll down to where we had the other one. We'll do another public static string tree facts. Open that up. And just should have a get. So in this case, we'll just return tree facts. So it's telling me that field forest.treefacts is never assigned to and will always have a default value null. I think that's because we just actually, I'm not 100% sure why it would only have a default value none. We do get the blue check mark here, so that's good. Define a public static method named print tree facts that writes the value of tree facts to the console. So then we'll do a new method down here that is a public static method that will return a string variable. Actually, it doesn't return anything, so it would just be void. But we will do print tree facts. Open that up, and all it should do is do a console.writeLine and print the value of tree facts to the console. Note, tree facts is never assigned a value, so we'll resolve that. Obviously, is never assigned to, so that's why we're getting that error. Static constructors. An instance constructor is run before an instance is used, and a static constructor is run once before class is used. The constructor is run when either one of these events occurs, before an object is made from the type, before a static member is accessed. In other words, if this was the first line in main, a static constructor for forest would be run. It would also run if this was the first line in main, forest.define. Typically, we use static constructors to set values to static fields and properties. A static constructor does not accept access modifier. In the previous exercises, our tree facts and forest created fields were never given values, so we'll fix that. First, create a static constructor for forest. So we'll create a static constructor for forest by just doing forest f is equal to new forest. Not contain a constructor that takes 0 arguments. Let's take a peek back up here. And months before class is used. Let's get rid of this bit here. It wants us to create a static constructor for forest. So up here in the constructors, we would just do static forest. Let's run that and see if that works. That does. Never assigned to, and we'll always have a default value null. In the body of the static constructor, set the tree facts field to this string. Okay. Wouldn't be a video if I did not forget the semicolon at the end. Still have an error here, so next we'll set the forest created property to 0. Okay, cool. Did that correctly. All right, static classes. We covered a few static members: field, property, method, and constructor. What if we made the whole class static? A static class cannot be instantiated, so you only do this if you're making a utility or library like math or console. These two common classes are static because they are just tools. They don't need specific instances and they don't store new information. Now, when you see something like math.min, console.writeLine, you know that these are two static classes calling two static methods. We rarely create static classes on our own, so let's practice using other static classes. First, print the value of pi, a commonly used value in geometry, which is stored in math.pi. So it's just wanting us to print, so we'll do a console.writeLine math.pi. Perfect. Let's next find the absolute value of -32. The method returns the absolute value or positive version of the argument. Print the results to the console. So we do math.abs for absolute value, and then we'll do -32. Perfect. Common static errors. With great power comes great responsibility. If you plan on using static, you must be familiar with the errors you might cause. Here are a few common ones. This error usually means you labeled a static constructor as public or private, which is not allowed. Forest.forest static constructor cannot have an access modifier. This usually means you've tried to reference a non-static member from a class instead of from an instance. An object reference is required to access non-static field, method, or property forest.grow. This usually means that you try to reference a static member from an instance instead of from a class. Forest.treefacts cannot be accessed with an instance reference. Qualify it with the type name instead. So let's fix this error, CS0515, which is this top one. Static constructor cannot have it. So let's run it quick, see where that error actually takes place. It looks like it takes place on line 27. If we go down here, it's saying that This error usually means you labeled a static constructor as public or private, which you can't do, so we just have static forest. All right, we fixed the first error. Second error is CS0120, which is this one right here, and it's on line 11, it looks like. So on line 11, it says that you tried to reference a non-static member from a class. So we have int forest private string tree facts. It means you tried instead of from an instance. An object reference is required to access non-static field. Try to reference a non-static member from a class instead of from an instance. An object reference is required to access non-static field, method, or property. Let's take a peek at the hint. In program CS, call the grow function from the instance f. Am I missing something? 11, line 11. And then it says line 13. Might need to take a peek at the solution here because I am a little bit lost. I don't even see any. Usually it highlights where the actual changes are. Yeah, program. Oh, we had to go back into program CS. I wish I would have said that. Because program. Oh, that was my mistake. I was sitting in forest.cs looking at line 11, but it's actually program.cs. So we had to go over to program.cs and fix line 11. Instead of forest grow, we would do f.grow. That makes sense, obviously. Finally, we're going to fix CS0176. Remember, forest.treefacts cannot be accessed with an instance reference. So in this case, we're going to look at CS line 13. We have a console.writeLine treefacts. We're trying to access it from that, where we should be doing it through forest object. Perfect. Main. Now that you're familiar with classes, you're ready to tackle the main method, the entry point for any program. You've seen it many times now, but you can explain every part. Main is a method of the program class. Public, the method can be called outside of the program class. Static, the method is from the class name, program.main. Void, the method returns nothing. String args, the method has one parameter named args, which is an array of strings. Main is like any other method we've encountered. It's special use for C#, but that doesn't mean you can't treat it like a plain old method. So yeah, we've learned basically everything in here. Namespace, not exactly, and using system, not exactly. But we have a class called program. Inside we do static void main with strings arguments. If arguments.length is greater than 0, main phrase, string.mainPhrase is equal to string.join and args. My favorite fruits are cool. Each time we run .NET Run, the main method is called. We can include arguments on the command line like .NET Run arg1, arg2, arg3 that will be converted into an array as args in the perimeter. In the console, write .NET Run mango, pineapple, banana. Of course, we're gonna not do lychee or whatever it is. Oh my gosh. It's gonna make me do it. Perfect. All right, let's take a bit of a review here. Congrats, you're now ready to use static throughout your classes. In general, static means associated with the class, not an instance, and a static member is always accessed by the class name rather than the instance name, like forest.area. A static method cannot be accessed by non-static members, and vice versa. A static constructor is run once per type, but not per instance. It is invoked before the type is instantiated, or a static member is accessed. Either of these words would trigger a static constructor of forest, or forest.define. A static class cannot be instantiated as members are accessed by the class name like math.py. From program.cs, print the number of forests created. So if we do console.writeLine, and inside that, let's take a peek inside forest.cs and see exactly what we want to do. We want to print the number of forests created. So we have a forest created variable. So we would do something like forest.forests created. Instantiate two forest objects. So next we're going to do two forest objects. I'm going to do forest f is equal to new forest object with the name DMX home. And we'll do forest g is equal to new forest. And in this case, we'll do Amazon, and I believe it would take another one, which we'll do 200. Now we'll print the number of forests created again. When we view the solution, what happens? Oh, it's because I'm actually not supposed to put a. We'll wrap a string around it just to say that it is a string. 2. Before moving on, make sure you can explain how this value is changed. So forest created kind of checks how many actual forest values we have absolutely created, and since we created two new ones, F and let's not get that open, and G, it's created two new forests, so it goes from 0 to 2. Cool. All right, we do have a bit of a quiz now, which is fine. Let's take a peek at the syllabus here and see. We may have a project after this. Given this definition of main, which of these statements is true? So main returns nothing. I like that because the void argument typically means that it returns nothing, so I like that the most. Correct the return type void, which means it returns nothing. What is true about a static class? It has no members. All of its members are private. It cannot be instantiated. It must be instantiated with a static constructor. I like the top one. And it can't be instantiated. That's false. A static cannot be instantiated. That was a bit of a mistake there. We might have to redo the quiz now, but that's okay. We'll be all right. Call the static method toBoolean, which is defined in the convert class. It should take the argument answer. So we're going to use convert.toBoolean on answer. Cool. When main is run, what is printed first to the console? So it would probably do Space Invader .beep. .beep is a static that just writes beep beep. Oh, well, now we're really gonna have to redo here. Console.writeLine. We're really gonna have to redo the quiz here. This was bad. The forest class has a public static forest created property, a public static define method, no instance constructors explicitly defined. Which of these statics will cause an error? Or which of these statements, sorry, will cause an error? So first one is jungle.define. Yeah, I like jungle.define for throwing an error because we have the static constructor here. We create a new option. Yeah, it's going to be jungle.define. Last one. Why will this class definition throw an error? Each dollhouse has a number of rooms. No constructor is defined. Number of rooms is not assigned a value. The static method describe attempts to access the instance field. Number of rooms. Number of rooms is private. It's within the same class, so this one shouldn't matter. The static method describe attempts to access the instance field. I believe it would be this one because statics can only interact with other statics, right? A static method cannot access non-static members, so this will cause an error. Yeah. So we are going to have to retake the quiz here, and that's fine. Just because this one only had 6 questions and we got 2 wrong, so we don't want to get out of here with only a 60% or something like that. Which of these statements is true? It is the exact same questions, and that's fine. I don't expect them to have a pool of questions. What is true about a static class? It cannot be instantiated. Correct. Static tools classes are just tools. They don't need specific instances, and they don't store new information. All right, let's do the same one where we do convert dot to Boolean and answer. Perfect. When main is run, what is printed first to the console? In this case, it was aliens detected. The static constructor is invoked before a static member is accessed or the type is instantiated, right? So even though we did a static constructor, it doesn't mean it actually prints it to the console. So instead we have that. The forest class has a public static forest created property, a public static define method. So which one don't we like? Again, I'm going to stick with that answer of jungle.define. And then for this last one, we're going to say that attempts to access a instance field number of rooms. Okay, now we're on perfect. Let's continue learning, and we should be able to finish this video out with a fun little project. So this project is called the Object of Your Affection. Your friend is building a new matchmaking service, the Object of Your Affection, or OOYA for short. Don't worry, you still have time to convince them to change the name. With your new understanding of C# objects and classes, your friend thought you should build a pretty well-organized system of dating profiles. Your first step, build a profile class that allows users to generate profile objects. The profiles should store the following information: the user's name, their age, the city, the country, their pronouns, and their hobbies. And this is how it should be able to interact with your own profiles. Create a new profile with some information, add hobbies, and view profile. Let's get started. Let's tab over to profile.cs and set up the skeleton for the profile class. So to set up, we're going to do class and profile. Inside of it, we will open it up. Actually, I don't believe we do that. Yeah, we're just going to kind of do something very similar to this. And we are going to add following fields. So in the fields, we'll have a, well, first we'll assume properties are used to validate. Okay. So we'll do string name, int age, string city, string country, string pronouns, string, oh my gosh, hobbies. Property, but we'll use fields. Properties are used to validate. So have we done this kind of correctly? Yeah. So we've defined the field. I'm going to add a double hash that just says fields. Number 3, tab over program.cs. In main, we are going to instantiate a new profile object called Sam. So we'll do a profile Sam is equal to new profile object. And then we'll do sam.name is equal to Sam Dracula. Dracula? I don't know. And then we'll try our code by using .NET Run. So that's exactly what I did, but it's giving us an error because in program.cs we try to due to its protection level. So I assume I'm going to go back in here, and in the lane I'm going to just add public to all of them to start. Now if we do the good old-fashioned .NET Run, these are not actually errors, so we are all good. It's just because we haven't actually set values to them quite yet. Going public, yikes, what was that error message all about? Something to do with profile.name being private. Oh, that's right, all the members include a class name that are automatically set to private. To make this more clear for ourselves, make the access level explicit. Add private to all the fields you created. Of course, lovely. So we are going to instead do private instead of public. Could have just scrolled down to see what was going on, but instead I tried to figure it out by myself and screwed myself. So this time we're going to do private for all the fields. All right, users should be able to add their profile information in a constructor. Below the names, declare constructors for profile that allows you to set name, age, city, country, pronouns, given this a default of they, them, just in case it's ever left blank. Define a constructor in profile.cs and set the fields to the values passed. Make sure to also set hobbies in an empty array of strings. Use this to differentiate parameters from instance fields. For example, this will work, but this won't. Okay. So now we're going to go down. I'm going to do another / and do constructor. So in the constructor, we're going to do public profile. We will, below the constructor that allows you to set, so string name, int age, string city, string country, string pronouns is equal to they / them. Actually, we want to open up that constructor and do make sure to also set hobby to an empty string of arrays. I think I can just do that. Let's take a peek at the hint here quickly. String pronouns equals they, them. So yeah, that's what I've done. I'm a little confused on the string one. So for right now, I'm just going to leave it blank. I want to check and make sure that this looks good, because I'm not exactly sure where to put inside the constructor. Make sure it also use this to differentiate parameters from instance fields. For example, this worked. differentiate parameters from. So we would do something like this dot name equals name, this dot age equals age, this dot city equals city, this dot country equals country, this dot pronouns equals pronouns. Okay, let's save. Let's test out our code. If you assigned Sam a name in program CS before, remove that line where Sam is constructed, pass in the following information. So now we can just pass in the information where we say Sam Dracula 30 New York USA. Oops. He is him. Okay. Then run our code. So we're going to save this. .NET run. And it looks like it worked. Perfect. Nice work. But how can you access profile information once it's been added? We could use properties, but we'd like users to see all the information in a single formatted string. Time to add a profile view method. In profile.cs, define a new method. So I'm going to go down. I'm going to do a double and do methods just to have all of our stuff kind of figured out. Method under the constructor, it should have public access, return a string type, and have no parameters. So public, it wants to return string, and view profile. In that method, we want to return type string, have no parameters. It should return a string containing all the profile's information. Let's take a peek at the hint here. I was thinking of string interpolation and new line symbol to create the string. All right, I guess we can try this out and see how this ends up working. We'll say name, name variable, and after that we'll do \n, then we'll do age, put in age, \n, city, in city, \n, country, put in country, \n, then do pronouns, oh my god, fucking nose is always so fucking itchy. Pardon my language there. Okay, let's save this up, and then in main, we'll do a test out the method on Sam. We do Sam dot view profile. what happens when we click save and then .NET Run. Profile.view profile, not all code paths return a value. So if we go back to profile.cs, it's saying in line 27 in view profile that not all code paths return a value. Let's see if we've defined view profile correctly. I see. So it wants me to actually do sam.view profile, save this to a may still just give us an error here. Yeah, not all code paths return a value is an interesting statement because we have name, age, city, country, pronouns. Is there a, see there's a walkthrough for this. I'm not wanting CS0161. In 27 here. String.view profile. If we just comment out the hobbies line for just a second, what happens? So it's not string.hobby. When I call it on Sam, did I give it 5? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Not all code paths return a value. Is it possibly this? These \ends. I don't know why that would throw an error, but possibly. Yeah, I'm gonna quickly relaunch the page. Code paths, return a value, C# compiler error, not all values. So the compiler doesn't get the intricate logic when you return the last iteration of the loop. Let's check and see. We're missing a return statement, perchance. This is a good one, guys. I'm getting a little stuck here. I believe all the previous steps I did correctly. So it's just this one right here. If you remove that line, which I did. It should take no parameters, return type of string. string return type. It should return string containing all the profile's information. Constructor, it should have public access. Return type of string, the parameters string. We do string interpolation. Let's see. I know there is a walkthrough for the project, which we can grab really quick. Let's just see if I can possibly skip ahead and see how they were able to accomplish this goal of having the profile. So when I set up the new profile here, in the view profile, he does string interpolation like me. And then, that's what I'm doing wrong. So in the actual method here, we actually have to have a return statement. So we should return bio, right? Which makes sense. That's an easy fix. Obviously, if we have a return, we should have a return in the statement. So now, as I go along here, we should be able to click save and do a .NET run. And I'm hoping that, yep, okay, perfect. Now it does do this little weird thing with the centering, which is obviously something that we may want to get rid of. Let's get rid of that by doing something like this, maybe. All right, perfect. That looks really good now. So perfect, we figured that one out in main, test out the on SAM, and we now need to do hobbies. So this was the one that we didn't originally do. So in profile DCS, declare a new method called set hobbies. So we're gonna go down here and create a new method called set hobbies. It should have public access. It should have no return value, but then we'll call it set hobbies. Any parameters? A string parameter named hobbies. So we'll do a string parameter named hobbies. And inside here, it should just set the field this hobbies. Oh, sorry, this. Oops, sorry about the Discord nodie there. I don't know how I'm getting Raid Shadow Legends fucking... Okay, sorry. I'll chill out. To the hobbies argument. Great. I'm going to actually uncomment this now. Go back to view profile and modify the method so you display a profile's hobbies. Remember, you can loop through this hobbies to access each element. Go back to view profile and modify the method so you display a profile's hobbies. So we'll also do \n hobbies add some hobbies to Sam. So if we now go above printing out his profile, we can do set his hobbies by doing sam.setHobbies equal to a thing. So programming, programming, swimming, Gaming, of course, why not? I'm not going to add those ones because those ones are a little silly and long. If we click .NET Run, what happens now? All right, so missing some of these, obviously. So let's go back into program.cs. Did I do something wrong here? .set hobbies. This was really bad syntax, actually. Made a lot of mistakes here. Hopefully that's a bit better. Let's click .NET Run one more time, even though we're lagging quite badly now. Lot of errors. Line 10 of this, so it's this set hobbies is what I'm messing up here. New string. Let's relaunch the page really quick to get rid of all this stuff in the console, so we're not lagging. I'm doing the sam.setHobbies a little bit wrong here somehow. Let's keep going down. So it wants us to use sam.setHobbies, right? So we'll do that. And before we do that, we'll create a new variable or a new array called new string. We'll do string sam hobbies is equal to new string, and then what did I have? Coding, swimming, gaming, and then we do sam set hobbies with sam hobbies instead, something like that perchance. Let's try this instead. Identifier expected in line 33 of profile.cs. So if we go down here, 33, it wanted us to have an identifier expected. So let's again get the guy with the video in here to try and help us with the hobbies thing here. Something isn't exactly right. In the profile, he's adding a for each statement. Basically, okay. So in here, instead of doing this, he will instead do something like bio plus equals, let's see what he actually did here. Bio plus equals string interpolation into a quote that says I should really have had this better figured out. Oh my gosh. Let a backslash in up there. Then we'll do hobbies Is this what he did? Why would he do this? And then I'm really confused on why he did it like this. For each hobby, string hobby in, is that how you spell hot? Yeah, I guess it's HOBB. In hobbies, we'll open that up and say bio plus equals another string interpolation where we will say hobby \n, and we actually have to move this return statement down here, v return bio. So now what happens if we do .NET Run? Keep saying that identifier expected. Okay. If you call view profile before calling setting hobbies, you get an error. Fix that class so you can view, fix the class so that you can call view profile without adding hobbies. Convert the class. Okay. So you need to give over a way to set hobbies. So he's gonna create a new method called set hobbies. What is this? Oh my gosh, this might be the reason why I'm messing up. I think that might literally just be the reason that I'm messing up here, because I messed up the actual syntax of how this works. Yeah, this could very well be. Let's try to do .NET Run now. So yeah, that was it. I mean, if you spotted that one, good eye on you, but I had literally just put the name hobbies inside of the string because I was not paying attention. Stuff like that happens, but now I'm going to just reload it one more time here, and we'll do our .NET Run and see that our profile thing works. So we have all 12 of these. If we do .NET Run, we will be able to spot that, yes, we have our profile, name, age, city, country, pronouns, hobbies. So, perfect. All right, let's take a peek at what is up next. Interfaces is what appears to be next on the board here. And I don't believe we actually have too many more chapters inside of the C# intro, right? If we kind of look here, we are through a lot of stuff. We've finished data types, logic, methods, arrays and loops, classes and objects. Now we're doing interfaces and inheritance, references and lists, and LINQ, whatever that means. So we should have a good amount of more videos here still left in this, but that's going to be doing it for today's video. If you did enjoy, please be sure to leave a like, subscribe, and comment down below any comments or tips that you have for me. If you hopefully have a good rest of your day. I'll see you in the next one. Peace out.